What up, everyone? This is LeetCode 100, same tree. So we're given the roots of two binary trees, P and Q, and we have to write a function to check if these trees are the same or not. Two trees are considered the same if they are structurally identical and the nodes have the same values. Okay, so example one, these trees are the same, right? Structurally, they're identical. Their node values are the same. Example two, these trees are structurally not identical, right? Because root given the root of this tree P, it has a left subtree, but given this root of this tree Q, it doesn't have a left subtree. It instead has a right subtree, right? So structurally, these are not identical. So we return false. They're not the same tree. Now, example three, these are the same tree structurally, right? They both have the root node has a left and a right subtree for P and Q. But the values are different, right? For example, when we go left on this tree called P, or this root node P, when we go left, we have a value of 2 for this node. When we're at this root tree Q, we go left, we have a value of 1 instead of 2, right? So structurally, these trees are identical, but in terms of the node values, they're not identical, so we return false. Pretty simple, right? So there's really just those two conditions we have to consider is if they're structurally identical and if the nodes also have the same value. Okay, so we're going to use a DFS function for this, right? As you might imagine, because we have to kind of traverse the trees. So we're given P and Q as parameters. Okay, well, how do we know if these how do we know when we return true and when we return false? Well, let's handle the case where we have no node P and no node Q, right? In that case, we return true. Why is that? Because if we have a case like, for example, we're at this leaf 2, and we're at this leaf 2, right? They have no left and right subtree. So when we go left for P and for Q, we're both going to return none, right? So we would have no P and no Q in that case, so it would return true, right? So when P and Q both don't exist, that would be kind of like a case where uh, we return true. For returning false, though, first let's handle the case of if the trees are structurally identical. Okay, so let's think about this. What does it mean for these trees to not be structurally identical? It means that when we're traversing the trees, we're going to go down a certain path where one of these trees is going to have a particular node, but the other one won't, right? For example, if we start at this one, when we go left, we have a subtree here, right? Or we have node 2. When we're here at this one, though, when we go left, we have nothing, right? So we have P, but we don't have Q. Likewise, when we go right, well, we're not going to have P, but we are going to have Q. So one of the nodes exists, but the other one doesn't, right? So we're going to say if not P or not Q. And we don't have to handle and, right? Because that's up here, right? If they both don't exist, we don't have a problem. But if one of them exists and the other one doesn't, that's where we run into problems, which is why we're saying if not P or not Q. Additionally, we don't have to just worry about if they're structurally identical. We have to worry if the nodes are the same or have the same value, right? So we're going to say if or p.val is not equal to q.val, right? In these cases, we return false, right? So we're checking if the trees are not structurally identical or the node values are not the same, we want to return false because they're not the same trees, right? And we're gonna have to basically call this function on p.left, q.left, and also we want to make sure we consider the right subtrees starting at the root node. Okay. Now, of course, we actually have to call this function, so we're going to call on P and Q, which is our parameters. Okay. So yeah, really, this is the important code, which is right. Are they not structurally? If they're not structurally identical or they're not the same value nodes, we're going to return false, right? Likewise, if we hit a point where both nodes don't exist, we return true, which, kind of like our base case for exiting the tree. Right? Because when we're at when we're at like a leaf node and we go left and right, well, this 2 doesn't have any child nodes, neither does this 2, right? And so it's kind of our base case for when we hit the bottom of the tree. And of course, we would return false if at any point we at any point we detect that the tree is not um, that the trees are not identical. Um, you can also kind of call this recursive. You can also kind of recursively call this function. You don't have to make a DFS function, um, right? So it's the same logic, right? If not P and not Q, we return true. But if not P or not Q, or P dot val is not equal to Q dot val, we return false, and we can return self dot is same free P dot left, Q dot left, and self dot is same free P dot right, Q dot right. Right, I mean, it's kind of cleaner to write it this way, but I just wanted to show it with the DFS function first, just so it's a little bit clear. But obviously this is much cleaner, just calling this function on itself. Um, but yeah, I don't think this problem is too hard, honestly. It's probably one of the easier tree problems you can do. You just have to make sure you understand what conditions would cause your tree to not be identical, which is they're not structurally identical or the node values are not the same. Okay, so not too bad. I hope this helped. And yeah, I'll see you in the next one.